Hello everyone, this is the second, actually the third lecture, but the second actual lecture of and module 2 of S2A 2023, and we'll go through page 3 up to page 10. So today we'll talk about the different types of data. The first type of data that we have is categorical variables, in which we place the observation into groups. So the collection of data is divided into groups, and usually they are summarized by percentage of the observation in each group. An example can be the gender or the number of right-handed, the right-hand student compared to the left-handed, etc. The other type of variables are the quantitative variables, and the quantitative variables, they have like two subcategories. They are the discrete and the continuous. So this is called discrete quantitative variables. This is called continuous quantitative variables. Quantitative variables, they take on like numerical values, while the categorical variables, they take usually like a letter grade or male, female, or they can be either character or like usually, or they can even be numbers if they're like grouping. And the quantitative variables, the key feature are the center average and the spread or in other words, the variability of the data. So let's start with the discrete. The discrete variables are countable, and they take only a finite list of possible outcomes. And an example is like the number of students in a class or number of kids in a family. Now the second subcategory of continuous of quantitative variables are the continuous one, and these take infinite number. They can take in infinite list of possible values. They're actually the data points can be in the interval of any kind of like it can be any real value, so 1.5, 1.222, etc. So for example, the average, it's like continuous quantitative variable, and usually so they are like counted in large intervals. So an example can be the height or the weight or the distance or the average of a number. Now we'll go to see an example where we'll put each of the variables in the corresponding like type of variable that they belong, either categorical or quantitative, discrete, or continuous. So these are the student names and their codes, and these two are considered like subjects because they work like identifiers of the subjects, right? And these, the 1, 2, 3, 4, the year, the major, the exam 1, 2, project 1, 2, the absence, and average, and grade are all like variables. Like these are all variables. Now I want to like categorize. So as I said, these are two like not variables, they're like student identifier. So let's start with a categorical. So which one do you think out of these variables can be placed in the categorical? You can pause the video and do it by yourself, but and I will like answer after. So if you pause and solve right now, I will place them. So as we can see, it's clear that the major is categorical, right? Because they're like a collection of information which is divided into like groups. This group 1, group 2, group 3. Another one is the grade, right? It's a collection of information divided in a group, and they can like describe by percentage. So you can say how many percent of students belong in this major, or how many percent of students they received a letter grade of D, right? So I would put these two over here. Then the discrete quantitative variables. These are like finite list numbers, integer, but we can count them. They're not like they're they're finite. So here is obviously the class. It's like year in school, not like it's not considered time over here. That's why we can put it here. So year in school is like take finite list, and they're like it's like countable, like 1, 2, 3, 4, etc. Then what else can we put over here? Oh, it's here. How many times they missed the class? So someone can't miss it like 1.5 times a class. That makes sense. So apps and here should be here in my opinion. And lastly, continuous quantitative variables. Even though the exam 1, 2, project 1, 2 are here like integers, here like yeah, as I said, we can like take their average and it will make sense, right? The exam 1 to average. That's why this like average, we can take the average. Also in the exam, someone can receive 78.2. It just this student didn't. That's why all this will be like continuous, because their average can be like points. Also the average is also continuous, right? It's clear because it's point, it's an interval. So we did this exercise. Now we'll go in another exercise. Actually, we'll introduce the three types of graphs. Uh, Three types of graphs for quantitative variables. So let's like highlight this, guys. Okay. Graphs for quantitative variables is like dot plots, stem and leaf plots, or it's called a stem plot, and histograms. This is a sample. These are the data points of grades on an exam for a small class. So let's start with dot plot. So first, to make a dot plot, we have to identify the median value of our data points. This is 45, and the maximum is 94. So we did was to put the lower and the upper like limits of the dot plot. The lower on the x-axis. The lower is 40. It has to contain the 45. That's why it's 40. And the maximum is 100. It has to contain the 94, which is over here. That's why we put the 100. And these like distances have to be like equal usually. Otherwise, yeah. So on the x-axis we have the grades. These are all grades, right? So let's start from the yellow, which is the 45. It's clear that it's in the between 40 and 50, 45. Then we have the 65, which is clear that it's between 60 and 70, because 65 is larger than 60 and smaller than 70, right? Then we have the teal color, which is here, and interesting thing is that we have two grades equal to 72, 1, 2. That's why these two dots are stacked one on top of each other, as you can see. This is actually, it has to be here, right? If this is correct. 82, 8, so this belongs 82, 86, 89, and 80, right? So this is like 8. So the numbers here are like larger than 80 but smaller than 90. 80 then is we put 80 here, not here. And then, yeah, so this has to like, and then we'll do the stem plot or stem and leaf plot. In this one, in this like a graph, we first place the first digit of our like numbers. These are numbers, right? So we place the first digit of the number, which is like from 82. The first digit is 8, right? From 76, the first digit it's 7, etc. So we place the first digit of the number starting from the smallest to the highest in a vertical line, which is called stem. So the stem contains the first digit or digit of the number. So each observed value, these are all observed values, must be first separated into two parts, the stem and the leaf. The stem contains the first digits and the leaf contains the final digit. So the leaf will contain 8, 2, 6, 5, 4, 2, 0, 1, etc., 6, 9. And the stems will contain the first digit. And we'll like put them in an ascending order and you will see that. So we put them here like this, right? As you can see. Let me like put this again here. So let's see. So we put in ascending order, which means from the smallest to the largest. So 4 is this 4. Then we have 5. There isn't any 5, but we have 6, right? We don't skip this, even though there isn't any number starting with first digit 5. Then we have the 65. We put the 6 over here. The 76. And yeah, let's go. It goes up to like 91, which is 9. But as you can see, we have to put these here numbers to which are called leaf. We do the same. Sorry, I just wanted to see the numbers as well, just to be sure. So the leaf contains, we have to like complete a number. So we are looking which numbers start by with first digit 4. It's just one number and it has like leaf, the final digit is 5. And then we do the same for all the numbers, but and also we put the smallest like second digits. So it's 80, 82, 86, 89. It doesn't start with 9, 89. It's like it's from the smallest over here through the highest. And the last thing that we have to do is like we have to put a key identifier so people can read it the correct way. So the key is that what we're putting is for the first like number, the 45, we're telling people that this means because it's that we're actually thinking where is the decimal point, because someone could mistake the stem of 4 and the leaf of 5 and confuse it with like 0.5 or 450. So the answer is, to be complete, it has to like contain the key as well. So this is the answer. What's this? Yeah, I mean, you don't have to contain this, but this is the answer. Finally, the histogram. which is used for continuous quantity variables. It's the same thing again. So we use this. We use like interval points because we have the smallest 45, right, and the largest 94, and we include the 100, and then we proceed. So each pin over here represents the interval where each of our values is contained in. So this pin is between 40 and 50. It has to be like here actually. So we have to go check how many numbers are contained between this interval, right? Between 40 and 50. And if it's just one number, like here, 45, if it's just one number, we just put one, it's called bin or bucket, one bucket. If we had 45, 46, 47, etc., so 3 numbers, we would put 3 numbers. So right now we have just one number contained in this interval, so we just have one pile, one bin actually, and that's why the frequency, if you draw a horizontal line, it's 1, right? Because only one value appeared in this interval between 40 and 50. Over here. Then we do the same for 65. It's straightforward. Why we put this, and it's just one number contained here, so the frequency is again 1, right? We do the same for the other 3 numbers. So this time, as you can see, like there are 3 numbers contained in this interval. So we have 3 piles, one on top of each other, and the frequency, since the 3 bins like are stacked, is equal to 3. And the y-axis corresponds to frequencies. These are the frequencies that have occurred. And again, this is the same with the segment. With the dot plot, 72, 70, 76 is the car content here. And here, same, it's like the same thing, right? The 80, we'll include it here. Because it's larger or equal than 80. So when it's larger than equal to 80 over here, the number, we put it in this, inside of that interval. So we are all greater or equal to 80 and less than 90. And we have 4 numbers, so we have 4 being stacked up to each other, one up to each other. That's why the frequency is 4. If we draw a horizontal line, so the frequency is 4, which means this is like the y-axis represents the frequency. It means that 4 numbers appeared in this interval between 80 and 90. And this is important because we don't want to include 80 here, but we don't want it here, because otherwise this would have been like this. So this is the correct. And the last 2 digits is like 94 and 91, and put it here. So the frequency is 2, and it looks like this if we do it by hand. So these are the grades, and this is the y-axis, which is the frequency. And we want to find for this data some information. We can see that the measure of center are like the mode. Let me write this. Mean, mode, median. All this. The center of distribution is around here, right? We can count the stack and see that is around the low 80 and the upper 80 because you can either like say it as median or the mean actually. And we can see it from the other two graphs too. And the spread is the values from minimum number to the maximum number that our data points take. So it's all this distance. So starts from 45, which is our lowest number if you remember of our data point, and goes up to 94, which is the maximum number. The shape is like approximately like bell shaped, maybe left skewed a little bit slightly, but it's roughly bell shaped. We can see it here. Then any unusual observation, we can maybe say that the 45, which is contained in this pin, might be like an outlier or an unusual observation, right? Because as you can see, there isn't any like data point over here, but we can say that. But, yeah. And we'll say we'll introduce some other extra shapes and distributions. So this is like bell shaped and it's symmetric because if we draw a line, it's bell shaped, and we know this because if we draw a line, it has this it looks like this, and it's symmetric because each data point on the right of this over here and here are like symmetric to each other. This is like symmetric, and this is like bell shaped. And this is like unimodal because it has only one mode, one up, one bump, which is here, right? One top maximum point. So some example of data which could look like this if we put them in a histogram, it's like the heights of people or the weights or the lengths of something. And if we take a very large number of the points, it will look like this, a normal distribution. And this is called uniform or rectangular because it's flat. Everything is equally likely. Every pile has the same probability of occurrence. It's like rolling a dice or flipping a coin, right? So it's rolling a dice because it's like 1, 6, 1, 6, 1, 6, 1, 6. So if we roll a dice, every number has a probability of 1 over 6 of occurrence. That's why the rolling of dice. Then we have the bimodal, which has two tops, which has two modes, two maximum, and this can describe two groups. One group is this, and the other group is this. That's why it has different mode, different maximum, different peaks, bounds. So this can be the population of the female's height, or this can be the men heights. It's called bimodal and combines two groups. Then we have a classic one, which is called a distribution is skewed to the left, and we can see this if we draw this curve. The tail is longer on the left side, as you can see, long tail on the left side, limit on the right side, and none on the left. An example can be the gradient in the exam, and in this situation the mean is smaller than the median when it's skewed to the left, so the mean to be on the left of the median. The opposite thing is skewed to the right, where the tail is longer on the right side. and the median this time is on the left side and the median right. And this example can be like the salaries. That's why there are few high salaries, while grade on unit exam there are a few bad grades. Everyone with a good grade. This is skewed to the right, and this is skewed to the left. Now we'll do these two questions. We'll describe. The shape is the curve that we're drawing, and the shapes are the ones that we previously described: left skewed, right skewed, bimodal, unimodal, etc. So about the measure of center are the mean, the median, and the mode, and the spread is usually the range, which is from the minimum point to the maximum. So from this point to this, the maximum, which is 85,000 in this example. So it says from 25,000 up to 85,000. This is the range. About the measure of center, the mean is clear that it's approximately around here. So let's draw this. Actually, it's around approximately like here, 45 like 1,000. So this is the center, this is the range, this whole thing, and the shape. It's approximately like this, and we can see that the shape is skewed to the right because it has a long right tail. The center actually was correct. In the previous attempt, this was here in the 45. So it's around here. It's around here. The mean, the average, and the spread is what we said, which was starting from here, 55,000 up to 85,000. This is the range, this distance, and this might be an outlier because it's far from the other pins, the 85,000, but it's not necessary like an outlier. So let's see the next example. And we want to describe this distribution. And as we can see, we have two peaks, right? We have two modes, two highs, up downs, which is this like considered like it is the mode 1, the mode 2. That distance we can see is all this. So the range or the spread is the maximum, so the minimum to the maximum, and the shape is like called bimodal. And because this is the mode 1, which is equal to 15, and this mode 2, which is equal to 85. And there are no outliers, which is clear, and the spread starts from here up to here as a set, and the center is around here, but of the mean, but it's better to use as measure of center. So use the modes as over. So yeah, this is a second example. Then we go in this third exercise, which has like different race categories, for white people, for African American, and for Hispanic. And we want to describe this distribution for each of the category of each of this for each of these three categories. So we start with a white cross race, and as we can see, slightly skewed to the right, or here. And we can see the average is mean is around 3%, and the spread is clear. It starts from -6% up to 18%. So it will look like this. The median is around 3%. It's better for when the distribution is skewed. It's better to use the median as measure of center. It's skewed to the right, no outliers. It's clear. Spread. Then for the other category, for African American growth, which is the other category of our race, we can see this time it's skewed to the right. It's clear, not slightly skewed, because if we draw this line, it's low, it has long tail. Then we can see the median. We use the median again because better when it's skewed. This here in the 15%, skewed to the right. The spread starts from 0, which is the minimum interval point, and it goes up to maximum, which is 120, and we have 3 outliers. It's 2 here because of the height of the pin, right? And 1 here because of the height of the pin. And so we are saying it's outlier because if we go back in the data, and this is the category, the current one, the African American, we can see that this yellow highlighted numbers are way higher than the other ones in this list. So we can say yes, there are 3 outliers. And the last example is that for the rate of Hispanic growth, as we can see, it's like bell shape, and the median is here, 75%. The shape is from the maximum to the 100, from the 15 up to 150, and there are no outliers, which is clear. So now let's continue with this example. Steve Spurrier is one of the most beloved Gator football figures, both as player for his University of Florida and as head coach for 12 seasons. When he resigned in 2001, he was replaced as head coach by Ron Zook, which was not a popular choice. Within a day of Ron Zook's hiring, one of Fan started a website called fireronzook.com. This website gained national media attention. He only lasted 3 seasons. But how bad was his record as a Gator coach? That's the question. The graph below is a histogram of point differential. This is a keyword. Point differential, it means points scored by the Gators minus points scored by the opponent. For the Gator football team under the Ron Zook. So, in other words, this histogram on the horizontal axis over here, this minus 30 shows the point differential score. It means, so in other words, when the point differential, as you know, is less than 0, it means Gator scored less than the points than the opponent, which means, in other words, when the point differential is a negative number, it means Gators lost, right? So whatever is on the left side over here, it means that the point differential is a negative number, right? Which means that Gators lost. So, and the y-axis, the vertical axis, shows the number of occurrences of the event that happened. So, in order to, for example, if we're interested in finding out how many games Gators lost, how many games Gators lost, we have to just add these piles, the bins up to this point. So this bin, this plus this bin, this, and this. So we have to draw know how to read this bin. So we know that this bin has its top point is stops over here, which has a frequency of 1. So this shows that only in one game the point differential was this low. So the key thing here is that this is the important information here is that the graph below is a histogram of point differential. What is point differential? Point differential is the points scored by Gators points scored by the gators minus points. Okay, the point scored by the opponent. So if the point is scored by the gators minus the point scored by the opponents, if the point difference is negative, which means the gators scored less points, it means the gators lost, because in every game, if someone scores less points than the opponent, in other words, if he has negative score of point difference, it means he lost. So I added this like these are the heights of the corresponding height, the frequency number for each of these pins. If, for example, if you draw a horizontal line over here, you can see that the pins that are in the same height with this one is these ones. It shows how many times something occurred in a specific interval, as we saw previously. So the 3, yeah, it has to be like here. It's like, for some reason my points aren't correct. So the 3 is here, the 4 is here, 5 is here, 6 here. So I just put their height number, which you can do it. So if you draw a horizontal line here, it's 6. Horizontal line here is every 5. Everything that is as top point here. This is the 4. This has to be here, as I said. It's like something happened, like wrong graphical error. So this straight line here is 4, etc. So when the point difference is negative, so when it means that gators scored less points than their opponents. So when it's a negative, it means we lost, right? The gators lost because they have negative points. So every point that is below 0, it means that these are the points different, the point differences in the x-axis. So the numbers in the pins. So 6 represents the number of games, the occurrence that something happened, the point difference that occurred in the interval actually of the point difference that appeared in how many number of games have appeared. So we can see like these are all the games that gators lost, right? The number of games, and on the other hand, and this everything which has positive difference is the number of games that gators won, because the point difference is positive. And the total number of games that the gators played is all games, like all the beans. So we actually answered all questions, but we can see it again. You could pause and answer the questions. How many games did the gator play under the Quran Zook? So we should sum all heights, right? All games, all beans. 1 plus 1 plus 3. These are the number of games correspond to the number of games, well, numbers in the beans, right? So we add all the beans, and the total is 40 games. How many games did the gator lose under the coach Runzuk? We lost everything which is like less than 0. This is a 0. Everything that is less than 0. So all this, like all this 6 plus 3 plus 1 plus 3 plus 1 plus 1. So we lost 15 games, and the next question is the worst game result for the Ron Zook. So we have to check the intervals. The worst game result was between minus 30. This has to be on the left. I think there's an error. So it's between minus 30. You will see in your copy, in your notes. It's between minus 25 and to 30 points. That's the highest, biggest negative value on the point difference, right? So it's the smallest number. The smallest number is the biggest negative, right? So this is like between this interval. Then we want what was the best game. The best game is the biggest positive value is over here, and 60 points, right? Point difference was 60. We scored 60 points more, the Gators. So Gators won by over 60 points and twice. Why twice? Because of the two, right? It says how many times it happened. The last question is how many games did the Gator lose by 15 points or more? So we want the lose, it means it's a negative number, the point difference. So we want anything that is less than negative 15. So anything on the left of this, right? So we add 3 plus 1 plus. It's pretty straightforward, and that's the questions, and you should redo this exercise if you didn't do it.